Hello everyone, welcome back to Geeks. And in today's video, we'll be discussing about our weekly contest 182. So like always, our contest was consist of 4 problems. And out of these 4 problems, our first problem we can say was really easy. And second problem was of medium level, from medium to easy we can say. And third problem was medium. And our fourth problem was somewhere from medium to hard level, right? So as compared to other contests, this contest was pretty easy, and we'll be discussing all these 4 problems in this video. So let's get started. Here we have our problem 1. The name of our first problem was max x, and the problem statement was: given a positive integer n, find the integer x such that 2 raised to the power x is lesser than equals to n, right? So in the problem we will be having an n, and in that n we have to return a x. With the help of that n we have to return a x, and the condition for returning that x will be like, we have to find a number which is in the power of 2, right? 2 raised to the power x, and that number needs to be lesser than or equals to n, right? So we have to find a 2 raised to the power, a number which is a power of 2, and it is closest to n. It will be a power of 2. It will be a power of 2, and it will be closest to n. Closest but smaller or equal, right? For closest, we can't consider the greater value. It needs to be smaller than n, or it can be equal to our n. As example, if we have our n like 70, right? So the closest power of 2 for 70 will be 64, right? And 64, we can represent 64 as 2 raised to the power 6. So if our n equals to 70, in that case we will be returning 6, right? Because the of closest power of 2 to 70 is our 64, which is smaller than 70, and 64 is represented as 2 raised to the power 6. So in case of n equals to 70, we will be returning 6, right? So how can we solve this problem? To solve this problem, we will be basically finding all the possible value of 2, all the possible power of 2's, all the power of 2, and we will be computing the power of 2 until it becomes greater than our given n. If somewhere it becomes greater than our n, then the value just before that will be our final answer, right? So what we will be doing, we will create a variable, let's say power, right? Power equals to, we are initializing it with 0, and let's say some I we are initializing it with 1, and we can run a while loop while our I is lesser than equals to n, and we will check if I equals to n, then return our power. Else what we will do, besides that this condition, we will be increasing our power, we will be incrementing our power, and we will be making I into 2, right? So how will I will iterate? Firstly, we initialized I with 1, and then it will go to 2, then it will go to 4, and then it will go to 248, and then 16. After that 16 into 2, 32. After that 64, and after that 128, right? And similarly, I initialized our power with 0, then as we runs through the while loop, it will increment it to 1, here it will become 2, here it will become 3, here it will become 4, 5, 6, and 7, right? Our power is representing the current power of 2. So in the case of n equals to 70, our loop will keep on running, until it reaches 128, and when it reaches 128 we will come out of our while loop, and at that moment the value of power will be 7, and what we will be returning, we will be returning power minus 1, right? Because we want the previous value which was either equal or lesser than my given n, right? Because we came out of loop when this condition became false. When will this condition will become false? When our power of 2 exceeds our given n, and in that case we are coming out of loop and we are returning the smaller power of 2, which is 64 here, right? So let's see the code will look similar. Yes, here's the code, a basic code. What we have done, we have created a we have initialized x with 0, and we have created a power, initializing it with 1, and we are running until our power is lesser than equals to n. And what we are doing, we are making our power into 2, right? So our power will go from 1 to 4, 8, then 16 up to like 128, then 256, then more and more 512, and we are incrementing power. It will go from 0, 1, 2, 3, 4, and here 7, and here 8, 9, and at the last we are returning x minus 1. So when the condition, when this condition become false, this condition is not satisfied, we will come out of loop, and when this condition is not satisfied, we know our power is greater than n, so we will return just 1 minus our power, sorry, 1 minus our x, which represents the exponential value, right? This represents this exponential value. So we are returning x minus 1. It will be our final answer. So this was the first question of this contest. Now let's discuss our second problem of this weekly contest. The name of our second problem is minimum time to burst balloons. Let's read the problem statement. Given an array positions denoting the positions of balloons on a number line, Geek wants to burst exactly k of these balloons. Geek starts at coordinate 0 and can move left or right along the number line at a speed of 1 unit per second. He can burst a balloon instantly when he is at the same position as that of balloon. Determine the minimum time required for Geek to burst exactly k balloons. So in this, what we have given an array. We have given an array which contains different numbers, which determines position of different balloons. It can be 0, 1, minus 2, minus 3, right? And we have our Geek standing at position 0, and Geek wants to burst k balloons, and we have to find the minimum time required to burst those k balloons. And how much time is required for each balloon? The time required for each balloon will be something like this. The time required for each balloon will be equal to the distance between the current position of Geek and the position of balloon, right? As it says along the number line at a speed of 1 unit per second. So for each unit, for like going from 0 to 1, our Geek takes 1 unit of time, right? So to determine the time, we will be calculating the distance. So we will be calculating the minimum distance that our Geek will be taking to burst exactly k balloons, right? So we have an array of size n which contains n position of n balloons, and currently our Geek is standing at a position 0, and we have to tell in how much time our Geek will be able to burst k balloons out of that array from n balloons, right? This was our question, and let's understand it better with the help of an example. Here we have an example. The k is given as 2, and we have a positions array given as 2, minus 1, and 4. right? So here is its representation on number line. Currently our person is standing at position 0, and these are the positions of different balloons. Position of our first balloon 2, our second balloon -1, and our third balloon at 4, right? So what are the different ways in which we can burst two balloons? First can be like bursting the balloon at -1 and then the balloon at 2. Second can be bursting the balloon at -1 then at 4, bursting the balloon at 2 and then -1, and bursting the balloon at 4 then -1, bursting the balloon at 4 and then 2, bursting the balloon at 2 and then 4, right? We can have multiple possibilities, and we have to tell which of these will be giving the minimum distance or minimum time we can say, and we have to return that particular distance or time. So let's take one of these examples. Let's take this one. If our geek goes here from 0 to 2, firstly he will go, so this much will for 0 to 2, from going sorry from 0 to 2 it will take 2 units of time, and now from 2 to -1 it will take him 3 units of time, right? 1 2 3, 3 units of time from here. And if our geek, so what will be the total time for 2 to -1? The total time is 5 units. And what if we takes this 2 4? So firstly, if our geek will go to this 2, it will take 2 units of time, and from this 2 to 4 it will take another 2 units of time, so it will take a total of 4 units of time. And similarly, let's take another example. What if we burst our first balloon at 4th and second balloon at -1? So initially it will take 4 units of time, and then it will take from 4 to -1 it will take 5 units of time, so the total is 9. And also if we calculate for other values, we will get this 4 units as our smaller. It will be the smallest value for the time taken by geek to burst exactly k balloons. So our output will be this 4, right? So that what this is what we're doing. We will be calculating distance for different balloons and for different k balloons, and we will be returning the smallest value, the smallest time taken to burst exactly those k balloons. So here, if we notice one thing, for the balloons 4 and -1, we took the highest time. The time was highest for the balloon at position 4 and -1. Why? Because the difference between the position of these two balloons, the difference was highest. And because of this high difference, our geek took more time to travel between these two balloons, and our time was also highest, right? So if we want our k balloons to take least time, if we want our k balloons to take least time, what we will be doing, we want to make sure that the difference between these k balloons will be smallest or will be least, right? So to make the difference between k balloons least, what we can do, as currently all the balloons I have, they are in any format, they are not arranged. Firstly, we will sort these distances, these position of balloons that we have, so they will be arranged something like this: -1 -2 0 2 3 and 4. After sorting they will look something like this. And here we have the leftmost balloon, and here we have the rightmost balloon. And now we will be comparing each k balloons. Let's say the size of k is 3, so we will be comparing 0 to k and finding the distance for them. Then so 0 to k -1, then 1 to k, and then 2 to k plus 1, and then 3 to k plus and then 3 to k plus 2, right? We will be calculating distance for all these balloons. And after calculating this distance, we will be comparing this distance and we will be returning the minimum distance. So after sorting our array, we can have three different possibilities of these k subarrays we are talking about, of these k balloons. What are those three possibilities? So those three conditions are, here's our first condition: if all the balloons lies on positive axis, right? If we imagine like all of our balloons are lying somewhere on positive axis, then what will be the total distance that will be taken? Firstly, it will take 1 unit of time, then it will take 2 unit of time, then it will also take 2 unit of time. It gives me a total of 5. So if all the balloons will be lying on positive axis, then the total unit of time that will be consumed will be equal to my largest value, right? Because we don't need to go to the negative axis, as all the k balloons are lying in my positive axis. So if I move from 0, then the maximum distance I'll cover will be equal to my greatest element, right? Because if I go here, I'll burst this 1, then I'll burst this 3, then I'll burst this 5. So if I am moving to some balloon and all the balloons that were occurred previously in that line, I have burst them all. So if all the balloons are lying on positive axis, then my distance, so distance, or we can say time, will be equal to the largest value among those k balloons, right? This was our first condition. And here's our second condition: if all the balloons lies on negative axis, if all balloons lies on negative axis, then what will be our answer? What will be our total time? So firstly, let's say we burst this balloon, it takes 1 unit of time. Then we burst this balloon, this takes 2 units of time. Then we burst this balloon, it also takes 1 unit of time. So the total time taken is 4. And here we can say that the total distance the total distance that will be traveled will be equal to the modulus of my least number, right? The most extreme number, the number on extreme left, will be my total distance that will be covered. The absolute value of my least number will be the total distance that will be covered, because as I'm moving on the left of the number line, like when I'm at this -3, I have already burst the balloon at this -1, and when I will be at this -4, I will have burst all the balloons that were occurred previously. So the total time taken will be equal to the absolute value of lowest lowest position right? Because it is in the negative, it is the lowest. Now here comes a third condition: if both the balloons lies on each side of the axis, right? They lies either on x-axis, sorry, lies either on positive side or negative side. Then what we will doing, let's say here we have one at 3, one at -2, and one at 2. So in that case, firstly we will go to the position which is closest, right? Then like if we go to -2, then we burst this balloon. It took me 2 steps, 2 units of time, and then I'll return to this 0. It took me another 2 units of time. Then I'll burst this balloon at 2. I'll burst this, and then I'll move to here. I'll burst this. So here I burst this balloon at -2. Here I came back to my original position at 0, and now I'll burst this balloon at 2, and now I'll burst this balloon at 3, right? So the final answer is 7. As we can see, as if all the numbers are on both the sides of my axis, both on the negative side as well as positive side, then one side I have to travel twice, then I'll be traversing twice, right? Like here I traversed this -2 twice, but if I was going on the positive side, then I'll be traversing this 3 twice, right? So if I will be traversing this 3 twice, my answer will be greater, and I want to minimize my answer, so that's why I'll be going twice for the least number that I have. Least number, that least number among absolute value of my left value, right? Absolute value of my left value, as left value can be negative or can be not, and normal value of my right value. So I'll take absolute of -2 comma 3. So which one is smaller? I'll be taking 2, so I'll add 2 twice, right? Because once for when I burst this balloon, and second when I came back to this origin. So I'll take this lower value that I have found twice, and then I'll add my rightmost value, or I can say the highest value that I have. Then I'll add this highest value, which is I have is 3. So 2 plus 2 plus 3 gives me the same output, right? So we will be doing this for our all K balloons, and to compare all the K balloons, we will be using sliding window technique. We will be using sliding window technique. As in the array we have discussed, as this array is sorted, now we will make a window of size K, and we will be removing this element and we will be considering this element, right? And similarly we will keep on doing this for each K. Now this will be the new window size, this will be the new window size, this will be the new window size. And what we will be considering, we need to consider only the leftmost value and the rightmost value, because whenever we traversing these left and rightmost values, all the occurrences of balloons that is occurring in the middle of this left and right will be covered, right? Here I have 0, here I have my right, here I have my left, and if any balloon is occurring here and here, so when I will move to my most left balloon, it will be covered, and when I will move to my most right balloon, it will also be covered. So I'll be considering only my left and right value. So this was the explanation for this problem. We will be firstly sorting our positions array that we have, and then we will be implementing sliding window on the array that we have formed, and we will be comparing each k-sized window, right? So now let's see the solution for this problem. Here's the solution. So firstly, we sorted our array, our positions array, which contains the position of balloons, and now we have created a size, and now we have created a res initialized with int max. In this we will be storing our least time, right? That's why we have initialized it with int max, to store the lowest time. So now we are running the loop from 0 to n minus k plus 1, right? As we have to create a window of size k, so we are running up to n minus k plus 1. For the window of size k, to get the last element of window of size k, we will be able to get only when we are running the loop up to n minus k plus 1, as we will be accessing plus k, right? I plus k minus 1, I plus k minus 1th element for the last element of our window. So what we have done, we have firstly pointing at our leftmost element, which will be the our ith element, and our right element, which is the I plus k minus 1, right? For 0, let's say our I equals to 0 and value of k is 3, it will be 0 plus 3 minus 1, 2. So our leftmost element will be 0 and our rightmost element will be 2, and here we will have 1 in between. It makes a window of size 3, right? So here we have our three conditions that we discussed. If both the if both of the position, the leftmost and the rightmost, are lying on my negative axis. If both the positions are lying on negative axis, then we are calculating the minimum of my current number and the absolute value of first index, right? As my first index is starting, as my first index will be largest, right? As we are talking about all the elements lying on the negative axis, so my first index, my leftmost index, will having the largest absolute value, right? So we will be considering that will be the total time taken. And if all of my positions are lying on positive axis, then we will be considering the rightmost element, which will be the largest value, right? Here we have a balloon, here we have a balloon, here we have a balloon. So we will be considering this position, right? Our rightmost position. And if our balloon is lying on both negative as well as positive axis, then what we have done, we will find our closer end closest to the current position of Geek, which is 0. So absolute of left hand and right hand, the minimum value will be closest. And to find the farthest value, we have used max, the max of absolute of left hand and right hand, right? We are using absolute for left hand because they can be negative, and this closer and farther end will give me the starting and ending position of my balloons, right? I'll be starting with this closer end. So like if the value of this closer end is -2 and the value of this farther end is, let's say, some 5, right? So as we are taking positive value, we will be taking this as 2, and for on the number line, here we have -2 and here we have -5 and here we also have some balloons. So when we will go to this -2, this is my closer end, closer, and this one is farther. And then, and when we will be moving to this closer end, firstly we will go there and come back from there. So we will considering this closer end twice, and this farther end will be considered only once. So our distance will be closer end into 2 plus farther end, right? That what we have done, we are taking the minimum of our current res and our current distance, or I can say current time, right? Closer end into 2 plus farther end, and at the end of this loop I will be done comparing all the windows of size k, and my res will be storing my final answer. After that I'm returning my res, it will be my final answer. So this was our second problem. What we have done, we have firstly sorted our array, and after sorting we performed sliding window technique. And in that sliding window technique we had three conditions: if all lies on negative axis, if all lies on positive axis, and lies on both sides, right? And here we had different implementation for all these three conditions. I've explained them, and at the last I'm returning my final answer. So now let's discuss our problem 3 of this weekly contest. The name of our this problem is count valid pairs. So what does the problem statement says? You are given a graph with n nodes where each node I has a weight wi. Undirected edges are present between two nodes I and j if and only if wi and wj is not equals to 0, where n represents the bitwise AND operation. The task is to find the total number of valid pairs in the graph. A pair of nodes I, j, where I is lesser than j, is called a valid pair if there exists a path between node I and j. So we have given a graph with n nodes, and each node I has a weight wi. So we have a w array, and this w array consists of some weights, some integers. It will be like 2, 3, 4, 5, and each element represents the weight of that node at that particular index, right? For this 2 represent the weight of the node 0, and this 3 represents the weight of the node 1, and this 4 represents the weight of the node 2. So if wi and wj is not equals to 0, where this AND represents our bitwise AND. So if like this node and this node, the AND operation between any of the nodes, let's say the node 0 and the node 3, if the AND operation between these nodes is not equals to 0, right? What will be the AND operation between these? It will be 10, and it will be 4, it will be 101. So it will be 0. So there will be no connection between these nodes. But if I consider 1 and 5, their AND will be 1. So there will be a path between these nodes. So if wi and wj, the AND operation between any two nodes, the weight of any two nodes is not equals to 0, where AND represents between the task is to find a total number of valid pairs, right? If the AND operation between any two nodes is not equals to 0, we can say that an edge is present between those two nodes. So we have to find how many pairs, what are the total number of valid pairs that can be formed. And a valid pair can be like, we have obtained something like this: 1, 5, 3, and 7. And I can say what will be the total number of valid pairs. One is this, other is this, other is this, other is this, right? So like 1 and 5 is a pair, 5 and 3 is a pair, 3 and 7 is a pair, and 1 and 3 will be a pair, and 1 and 7 will be a pair, right? So if there's a way to go from one node to another, we can call the pair of those nodes as a valid pair. So we have to calculate total number of valid pairs that will be formed, and when there will be a path between two nodes, when the AND operation between the weight of those nodes is not equal to 0, then only there will be a path between two nodes. So let's have a look at example. Here we have example. The given graph is 1, 2, 3. So what will be their binary representation? 1 we can write as 0001, and 2 will be 0010, and 3 we can write as 0011. So let's check the AND operation between 1 and 2. It will be 0. AND operation between 2 and 3, it will be 1. And AND operation between 1 and 3, it will be 1. So by this I know that there will be a path between the node 2 and 3 and the node 1 and 2, and there will be no path between our node 1 and 2, right? There will be only path between the node 2 and 3 and 1 and 3. So how will my graph will look like? The graph will look something like this. There's a path between node 1 and 3, and there's a path between node 3 and 2, right? So how many valid pairs can be formed? One valid pair will be 1, 3. Other valid pair can be 3, 2, and other valid pair will be 1, 2, right? 1 and 2, because as there was no direct path between 1 and 2, but I have to find how many nodes are connected. If I go through 3, I will be able to reach to 2. So I can say that node 1 and 2 are connected. There's a path between 1 and 2 through the 3, right? So one valid pair will be 1 and 2, and I can't consider other nodes, like I can't consider pair like 2 and 3, because it is mentioned that I and j will only be considered a valid pair if I take, like, here it will be 2 and 3. I won't be able to take 3 and 2, right? I and j will only be considered a valid pair if j is greater than I, right? Here my I is greater, so this won't be considered, right? The next element should be greater. Here, like, 3 was greater than 1, 3 was greater than 2, and 2 was greater than 1. So I won't be able to consider like 2 1 or like 3 1 or like 3 2. They won't form a valid pair. Let's see one more example. Here we have another array. These are the different weights. Weight of node 0, node 1, node 2, and node 3. So its weight is 1, 5, 2, and 10. It will be their binary representation: 0001, 101, 10, and 1010. So let's find their and values. What does 1 and 5 will give me? It will give me 1. 1 and 2 will give me 0. And 1 and 10, what will they give me? They will give me 0. So one I found is 1 and 5. And 5 and 2, 5 and 2 will also be 0. 5 and 10, 5 and 10 will also be 0. And 2 and 10, 2 and 10 will be 1. 2 and 10 will be 1. And yes, that's all. So how many pairs I can form? So the graph will look something like this: 1 to 5. Here we have a way, and other is 2 to 10. Here we have another way, right? So there's no connection between these two sets. So one pair is my 1 5 and other pair is 2 10. So the total number of pairs are 2, right? The answer for this graph, for this array, will be 2. The total number of valid pairs we will be able to find will be 2. So in this, what I will do, as we saw, what we have done, we found the AND operation of all the values, right? How we found the AND values of all these elements? By comparing their bits. So by step, I'll compare all the bits and those numbers who are having a common bit, right? Like if we check for the last bit, here I had only 1 and 5 had common bit. So I can say that 1 and 5 will be having a larger AND value than 0. The AND operation of 1 and 5 will be greater than 0 as they have a common set bit, right? And now I'll go to the second last. Now I'll check here. Yeah, one here, right? So here I can see there's a set bit between 2 and 10. So I'll consider 2 and 10 and create a set from them, because what will the AND operation between 2 and 10? It will be greater than 0. Why? Because they have a common set bit. Now similarly I'll do for this. I'll check for other bits. There's no one have common. Now I'll do with similarly with this, no have common. So 1 and 5 will be two sets whose AND operation are greater than 0. Now I'll form their set and I'll check the total number of bits that I can have. So what we will do, we will, let's take one more example. Let's take 1 6 8 and 10. Now for them, we will find their AND operation. For 6 it will be, for 8 it will be, for 10 it will be 1 0 1 0. So if now we will check for last bit, no one have common last bit. Now we will check for second last bit. Yes, 6 and 10 have a common second last bit. So I can say that 6 and 10 will form a path. And now I'll check for third last bit. No, there's no common. And now I'll check for first bit. Yes, 8 and 10 have a common bit. So I can say 8 and 10 will form another path. So what will my graph will look like? My graph will look like something like this. Sorry, 6 6, 10, 6 to 10, and 10 to 8, right? The total number of nodes will be 3. The total number of valid pairs will be 3, which is 6, 10, 8, 10, and 6, 8. Right? It will be 8, 10. So these will be my total valid pairs. Now, initially what I will do, I'll take all the elements for like 1 to n, right? These are the bits I have. So from 1 to n, if n is the size of my given array, I'll check the weight of each node, and I'll check for each bit for like for all the bits, for all the 32 bits that I have. I'll check for those bits, and if any of those bits have 1 in them, if any of those bits are common set bits, then I'll create a set from those numbers. Then I'll push them in a set, right? And after that, I'll be obtaining some graph. A graph can look something like this. The set that I formed, it can be something like this, and there can be multiple disconnected graphs, let's say 10 and 6, something like this. Now, out of this, what will I find? I find how many bits are connected with each other, and I'll find the total number of pairs. Out of those pairs, I'll return how many pairs are valid, and I'll return the total valid pairs that I have. So first thing we need to do, initially what we will be doing, we will be comparing all the bits of all the numbers that we have, and after comparing the bits of those weights, I will be forming a set, and in that set, now I have the information of all the bits that forms a connection between them, and those bits which have a path between them. And now I'll check how many bits, how many total set bits out of this can form a valid pair. Now how we will check for a valid pair? Let's see. So to check for the total number of valid pairs, let's see, we have a set something like this, right? And here we have our node 1, node 2, 3, 4, 5. So what will be the total number of pairs that we can have? So our 1 will form pair between this 2, this 3, this 4, as well as this 5. So this 1 will form 4 pairs, and now this 2 will form pair with this 3, this 5, and this 4. So our 2 will form 3 pairs. Now our 3 will form 2 pairs with this 4 and with this 5. Now this 4 will form a pair only with this 5, right? Through this path from 3 to 5, it will form a pair. And what will my 5 will form? 5 will form no pairs, as it have nothing greater than this. So the total number of pairs will be 4 plus 3, 7, 7 plus 2, 9, and 10. As we can see, the total number of pairs that is formed between 5 nodes were 10. And we can see our first node was able to form 4 pairs, which is n minus 1 pairs, and our second node was able to form n minus 2 pairs, third node n minus 3 pairs, and last node was able to form 1 pair. So we can say that if we have n nodes, the total number of pairs that will be formed between those valid n nodes will be the sum of all natural numbers, sum of all numbers up to n minus 1, right? So how we will calculate this? After forming a set, now we will check what are the total number of bits are there in this set, what are the total number of nodes that we have in this set, and after comparing those nodes, we will implement this condition, as we have to check for n minus 1. So the formulation will be n minus 1 into n divided by 2. As what is the formula for calculating the sum of natural numbers? It is n into n plus 1 by 2, right? So here our n is n minus 1. So what we will do, n minus 1 into n divided by 2. Here our n represents the size of set. the size of set that we have created. Now, how we will form this set that we are talking about? We will use disjoint set union. Disjoint set union. We will use this DSU data structure. And how this DSU will work? In this DSU, each set is represented by its parent element. Each set has a particular leader in it. So let's see if we have a set something like this: 1, 2, 3, 8, and let's say 10. Now it will have a particular leader, and let's say its leader is 1, right? So each node will be pointing towards its leader. So this node will point towards its parent node, which is 1, and this node will be pointing towards its parent node, which is 2, and it will point towards its parent node, which is 3. It will point towards its parent node, which is 2, right? And if we traverse all the parent any node and keeps on traversing, like what is the parent node of this 10? It is 3. Now what is the parent node of this 3? It is 2. What is the parent node of this 2? It is 1. And what will be the parent node of 1? There is no parent node, so the parent node of 1 will be 1 itself. So if we keep on traversing each parent node, 3, from 3 to now we have parent as 2, now we have parent as 1, now we have parent as 1, we will get the final parent. So each node has a unique parent, which is in which each node holds its respective parent. Now this parent that we obtain, we can consider it as its leader, and we can have another set joint, which we can say 5, 6, 7, and it has some 50 nodes connected to it. Now if we want to connect these two, what we will do? We will perform our union function, and if we want to connect these, we will check its size and the size of this set. Let's say these are two different sets, and we have to connect them with this 1 and 5. We will check what are the size of these sets. Let's say size of this set is 50 and size of this set is 5. So we will connect the smaller set with the larger set. So the parent of this one will become this 5. The leader of this whole set will become the parent of this, the leader of this set, right? So now the parent of 1 will change, and it is a common set now. It is now a singular set, right? That's how my disjoint set will work. We are going to form disjoint set, and in those disjoint set, we will count the set size of the different disjoint set that we have obtained, and with the help of that size, we are going to obtain our valid pairs, right? Now let's see the solution. How are we going to implement the solution? So here we have created our DSU data structure. We have a parent array and a size array. In this we will be, in this size array will be having the size of each node, like node 0, 1, 2, 3, size of each node, and this parent, as we have discussed above, it will be storing the parent of each node. Let's say parent of 0 is 1, parent of 1 is 1, parent of 2 is 3, and parent of 3 is 1, right? And now we have initialized our DSU data structure. In n, we will be obtaining it, we will be obtaining this from a function. Let's discuss this later. Firstly, come to our main function. This is our main function, count valid pairs. We have a W array which contain the weights of different nodes, right? With the help of this weight, we will be comparing those weights, and we will be checking whether there a path exists between any two nodes or not. Now we have calculated the size of this array, and we have initialized a disjoint set of the same size as of this array. Now here what we are doing, we are checking for all the bits. We are checking for all the bits that we have in our each element, right? All the bits of 10, all the bits of 32, and similar all the elements. and we'll be comparing those bits for I to n. And if any bit is equal to 1, if any two element is having a common bit, then what we will do, we will firstly store it as our first node. What does this first node represents? This first node represents the first node that is having that particular bit as a set bit, and all the other nodes all the other nodes that is having that particular, let's say we're talking about the third bit, and the third bit will be set bit of our, let's say, 4 firstly. So 4 will be become our first node, and after that my 5, 6 other will be added with the help of this d dot union. What does this d dot union will do? It will perform a union function, and it will form a set between them. So here we will have 4. Now 5 will be connected to this 4. Now 6 will be connected to here, and now other elements will be connected. So let's understand this DSU. So we have resized the parent as the size of the given weights array. We have currently all the elements, all the sets that we have is of size 1. What does this size array containing? It is containing the size of all the sets that we have, which is represented by their parent element. And now we are running a loop, and we are initializing all the elements as their own parent. Currently we have no set. So here we have two functions. This find function, what does this find function will do? This find function will return the parent of a particular element or of a particular set, right? What will it do? If an element has itself as its parent, we will return that particular element. If it is not, then we will keep on traversing, right? As we discussed earlier, like 3 has a parent 2, and 2 has parent 4, and 4 has this parent 1, and 1 has this parent 1. So we will keep on traversing until we reach the final parent, which will be like here in this case it will be 1. Now here's our union function. With the help of this union function, we will be adding two different set or two nodes, we can say. Now firstly we will find the parent of each node, and we will check if these nodes are not equal. And now we will compare if the size of which node is greater, right? If size of one of the node is greater, what will be the size of node represent? If that nodes form a prior set, like here are node 5, let's say it forms a set, and it's the size of this set is greater than the set formed by another node, so we will make this node as the main node, right? So here we are making the A as the main node. It will be become the parent node, right? If this 8 has no parent, so this 5 will become the parent of this 8. So if A is smaller, we are swapping them, and now we are making the parent of B as A, right? Because A was our bigger node, bigger set, we can say. Now we are adding the size of B in size of A, because now the size of this A has changed. This whole set is now become bigger, where the leader is A. This set is being represented by this 5, we can say, right? So this was our DSC function. Now we have compared all the set bits, and we have formed the elements those are having a common set bit as different sets, right? Now we have different set. Now what we will do, we will traverse through each set, and we will find their particular parent, and their parent will be storing the size of that particular set. Now we will get the size of that particular set. Now what we are performing here, we are performing here n into n minus 1 by 2, which represents the total number of pairs that we will be having. So for I equals to 0 to n, we are checking our all the sets, and in all the sets we are taking the size of those sets, and by doing size into size minus 1 by 2, we are taking all the valid pairs from each set, and we are adding them one by one to our answer. And now our answer will be containing all the valid pairs that can be found from my given weights array, right? So what we done in this, we compared all the sets. Let's say we had 3 sets. Now we compared their size. Let's say its size is 5, its size was 4, its size was 3. Now we found the total number of valid pairs that can be found. Like here in this case, it will be 4 into 3 divided by 2, it will be 6. It will be 3 into 2, it will be 3. It will be 2 into 1, it will be 1. So now we have added them. 6 plus 3, 9 plus 1, 10. Right? So our answer will be storing all the valid pairs that we found. Here our question is completed. If you have any difficulty, you can search DSU or disjoint set GFG, to get a better understanding how my disjoint set works. Right? So now let's see our fourth problem of this contest. The name of our fourth problem is Geekland and Tour. Let's read the problem statement. Geek is planning a tour of Geekland, a country with cities numbered from 1 to n. The cities are connected by roads, forming a tree with n cities and n-1 roads. Each city I is located at the location log of I-1, where the distance between two cities is the absolute difference of their locations. The roads in Geekland are represented by a list of n-1 bidirectional edges roads, where roads of j equals to uj, vj indicates a road between city u and city v. So in this we have given some 1 to n cities, and we have an array of size n. The name of the array is log, and in that array we have some elements, and each element represents the location of that city, right? So our 0th index will represent the location of first city, and our first index will represent the location of second city. Similarly, second index will represent the location of third city, and the element at fourth index will represent the location of our fifth city, right? And we have another array of array, which is roads, and at each particular index our array of roads is something like this, and it is containing different arrays of size 2. It can have some elements like this, and each array says that, like here we have 1 and 2, so it says that we have a route from the city 1 and city 2, and we have a road from city 2 and city 3, right? Each road of j equals to uj, vj, and it says that we have a route from city u to city v, right? That's what we have. And our geek wants to explore Geekland but has no money for traveling. However, a tour agency offers free rides for cities that are within a distance of less than or equal to k. Geek can start his journey from any city and wishes to visit as many cities as possible under given conditions. Your task is to determine the maximum number of cities Geek can visit without traveling any road more than once. So, our geek wants to travel multiple cities, and here we have a tour agency which provide free rides if distance between two cities is lesser than or equals to some k. And what will be the distance between two cities? Distance between two cities is equal to their location minus location of first city minus location of second city, and the absolute value, right? Absolute value of the difference between two cities, difference between the location of two cities will be our distance. And if that distance is lesser than k, our agency will be providing a free ride, right? So that's what we have. We have a lock array, a roads array, and a variable k, which represents the particular distance at which our tour agency will be providing free ride, right? So we have to calculate maximum number of cities. We have to calculate maximum number of cities our geek will be able to visit if he is visiting only for free, right? Because he has no money. So we have to calculate how many cities will be falling under this condition, and out of those cities, which cities will be our geek will be able to visit. So let's have a look at example. Let's understand it with the help of an example. So we have a lock array consisting of 4 cities, and we have a roads array consisting of 3 roads. So let's form a graph between these cities and roads. So our 1 and 2 are connected, 1 and 2 are connected, 2 and 3 are connected, and 2 and 4 are connected, right? That's how they are connected. So what's the difference between these? It is 1, it is 1, and it is 2. So as our k is equals to 1, our geek can move from 1 to 2 without any cost, from 2 to 3 without any cost, but from 2 to 4, as their distance is greater than our given k, our geek won't be able to move from 2 to 4. So as we have this 2 to 3 and 1 to 2, but this location array consists 1, 2, 4, and 5. In this location array, I have the cities my geek wants to travel. Here 3 is not present, so we won't be considering 3. So the maximum number of cities our geek will be able to visit will be 1 and 2, right? These will be our maximum number of cities. So the answer for this example will be 2. Right? Let's see one more example. Here we have a locations array 1, 2, 4, and 5. We have 4 cities, and in this we have 3 roads. Let's form a similar graph. City 1 and 2 are connected, city 2 and 3 are connected, city 2 and 4 are connected. And here we have 1, 2, 4, and 5. These are the cities my geek wants to visit, and we have a k equals to 3. So here the distance is 1, the distance is 1 here, the distance is 2 here. So if we start from the city 1, if we start from city 1, we will be able to travel city 2, right? As the distance is 1 and our k is 3, we will be able to travel there for free. And from city 2, we can travel to city 3, but city 3 is not in our array, so we won't be considering it. And we can also travel to city 4. So here we have city 4. And is there any other way of traveling any other cities? Yes, if we start from city 4, we can travel to city 2 as well as city 1, right? Our starting city is not fixed. We can start from any city as it was mentioned in the question. So what is the maximum number of cities that we can travel? It is 3, right? 3 here and also 3 here. So the answer will be 3. So what we have to do? We have to find how many cities have a road between them, and out of those roads, which road is having a distance lesser than k, and out of all those cities which are validating are these conditions, we have to find which cities are forming a network, so that if I'm going to 1 to 2, I can go to 3, but if I'm going from 4 to 5, I can't go from 4 to 5 with the help of this, right? If 3 and 4 are not connected, then I won't be able to go from 4 to 5. So we have to calculate the total number of cities, and we will be using these conditions. So firstly, to calculate, what we will do, I'll find how many cities are connected. So we have this roads array. We can create a graph with the help of this roads array, right? which will give me the total number of cities which are connected. And in the question it was mentioned that the cities and the roads forms a tree. So more than graph, we will be having a tree. Right, that's how it will look. And out of those roads, I will be only considering those roads whose distance is lesser than or equals to k. Because if their distance is greater than k, then I won't be able to visit them. So there's no benefit of having a road from like a city 2 to 10 if the distance is greater than my k. So I won't be considering those cities whose distance is greater than k. So I'll be forming a tree or graph, I can say, between the cities whose distance is lesser than equals to k and has a road between them. So what I'll do, I'll create I'll create a adjacency list. I'll create adjacency list to form a graph, and with the help of that, if I'll traverse this roads array, and if ui and let's say vj, each two elements, and we can call u1 or u0, has a distance, has an absolute difference lesser than or equals to k, then I'll be pushing them in my adjacency list. Then I'll be pushing them, I'll be do something like this: adjacency of u equals to v, and adjacency of v is equals to u. As the road is bidirectional, we can move to any city from other, right? And as while we are doing this, we will be having a condition. It will be in the if condition, and we will be traversing this whole roads array. So after obtaining this adjacency list, we knows how many roads I have which are having a difference of less than k, less than equals to k. And out of those cities, now I have to calculate which cities I will be able to travel. So now what I have the data which can, in which I have the cities which are feasible to travel for free, right? In all these cities, these are connected. This represents my number of roads, and these are my cities. Like each road is connecting two cities. This is a road, and these are my cities. So we have these roads connecting different cities, and we have to calculate what is the maximum number of cities I will be able to travel. So what I'll be calculating, as I look at by the perspective of tree, the maximum number of node. So we have to calculate the diameter of this tree, right? What is the diameter of the tree? The maximum distance between two nodes. The maximum distance between two nodes is known as the diameter of the tree. As here we can see my diameter, the distance here is 1 2 3, 1 2 3, and here the distance is 1 2 3. So our diameter can be either this or either this, right? But if we have one more node here, then our diameter will be this outer tree. And if we had like two more nodes here, then our diameter will be this inner tree, right? As the distance between them is 1 2 3 4 5, it is 5, and it is 1 2 3 4, it is 4. So we will be considering in which I am having more connections, more cities are connected, right? So what we have to do, firstly we will be creating an adjacency list, and in that adjacency list we will be finding our diameter, because the diameter which we will find, that diameter will be giving me all the roads that I will travel, right? How will I find it? I'll check if I go to this city, and if I go to this city, how many maximum cities I'll be able to visit. So that diameter will be giving me the total number of edges that I'll be traveling. So now let's see how we will be calculating that. So finding the diameter, right? To calculate maximum number of cities, to calculate maximum cities, we will be calculating diameter. And how we will be calculating diameter? So For a diameter of a tree, we know that two nodes which have the largest distance will be forming a diameter, right? Like if we consider this node and this node, these nodes are farthest for each other, but these are not farthest nodes in the tree. So what we will do, firstly we will find our two farthest nodes, right? So we will find the farthest node for this node, the farthest node for this node will be this, and then we will find the farthest node for our farthest node, right? So the farthest node for this node was this node. Now we will find the farthest node for this node, it will be this node, right? And I'll be calculating their distance, and I'll be finding the maximum distance between two farthest nodes, and I'll be doing similarly this for our each node. So for like my this node will be farthest, and similarly for like this node, for this node my farthest node will be this node, my farthest node will be root node. Will it be root node or this? No, it will be this node. So for this node my farthest node will be this node, and now I'll find the farthest node for this node. So I'll come to this node again, right? It can be a quite confusing. Let's simplify it. So what we will be doing, we will be checking each node, and for each node we will be finding the farthest node from that particular node, because to have the diameter between two nodes, right? If two nodes are forming the diameter of a tree, these nodes will be my farthest nodes, or I can say the distance between those two nodes will be maximum, right? So for each node we will be finding the farthest node for that node. So like for this node I'll find the farthest node, for this node I'll find the farthest node, for this node I'll find the farthest node, similarly for this, and for each farthest node I'll be again finding another farthest node. So like for this node, the farthest node will be, I think it will be this, and while I do that I'll be storing this distance, and let's say the max dist, I create something like this. And now if I find for another node, for this node, let's say the node with maximum distance is this node. Now I'll be storing that distance, and while doing that, in this variable I'll be storing the maximum of previous distance and current distance, let's call this, right? So to find the farthest node, to find our farthest node, we will be using DFS. With the help of DFS we will be going to each node, and if that node is, if we can move somewhere from that node, we will be similarly increasing our distance by 1. Like if we go to this node, we will increase our distance by 1. Now we will go to this node and increase our distance by 1 again, plus 1 again, and plus 1 again. And if somewhere it goes to null, we will return 0. Plus 1 plus 1 plus 1, we will have the distance here, like it is something like 6, and this 6 will be compared with my current maximum distance. If it is greater than the current distance, then it will be updated, my max distance will be updated if the current distance is greater than my max distance, right? That's what we will do. And after finding the maximum distance and comparing them for each node, what does my maximum distance will be containing? My max distance will be containing the diameter of the tree that we have, and diameter of the tree is what? Diameter of the tree is the count of the largest edges connected, right? the maximum number of edges which are connected, the count of them. And here like 1, 2, 3, 4, 5, 6, 7, 8. It will be 8, and the number of nodes will be 8 plus 1, right? Like we have two edges will be connecting 3 nodes, and one edge always connect 2 nodes. So if we have n edges, then the number of nodes that we are connecting will be n plus 1. As we have to return the number of cities, we will be adding 1 to it, one adding 1 to our diameter. That will be our maximum number of cities that we have to travel. Now, this was the approach that we will be following. Firstly, we will be creating an adjacency list, and with the help of that adjacency list, we will be finding the diameter of the tree, and after all of this, we will be returning that diameter plus 1. Now, let's see the code. So this is our code. So firstly, I have created some global variables. This is our visited array, in which I will be storing whether I have visited my previous node or not, or my current node. And this adjacency list I have created, in this I am storing all the nodes, all the nodes, I can say, all, or I can say all the roads which follows my given condition, and I can travel freely within those roads. So in the adjacency list, I'll be containing those roads, which is in the form of like city 1 and city 2, where city 1 and city 2 represent different nodes of the tree that I have, and it will also be containing city 2 and city 1, as each road is bidirectional. So this max d will be containing my maximum distance, and here I have a node. So this is the starting node, in which I will be containing my farthest node that I'll be calculating. I have initialized it with -1 because initially I don't know what will be my farthest node. So here this is my DFS function. We'll have a look at it later. Firstly, let's jump to our main function. So this is our main function. I have found the size of the lock array. It is the number of cities that I have, and now I'm resizing my adjacency list, because the number of roads will be the number of cities, right? It can be the maximum number of roads that I can have. And currently I'm marking all the cities in my visited array as 0, right? All the cities from 1 to n are marked as 0, because currently I haven't visited any city. That's what I have done, and I have resized my adjacency list, or I can say I have initialized it. Now what I'm doing here, I am creating my adjacency list. I'm traversing all the cities 0 to n minus 1, and if here this u equals to roads of I of 0, first city, as I am traversing the roads array, and the size of roads is n minus 1 if I have n cities, right? The number of roads will be 1 minus then the number of cities I have. Here v equals to roads of I of 1, so what I am storing it, here u will be containing, here u will be equal to our first city, let's say 1, and v is equal to our second city, between which our road is formed. Now I'll be traversing each u and v, and I'll be calculating if location of u and location of v. Why I have done this decrement? Firstly, let's have a look at this. Here, this city 1 and this is city 2. They will be present at I minus 1th location, right? In the location, if I want to find the location of the city 1, I have to traverse location of 0, and this city 2 will be having its location at location of 1, right? It was mentioned in the question. The nth city will be present, the location of nth city will be present at location of n minus 1, right? So now I'll have both of these locations and I'll check whether the difference between the location of these two cities is lesser than k or not. If it is lesser than k, then I'm pushing that in my adjacency list. And now I have created an answer. Here, up to this step, my adjacency list will be formed, in which it will be containing all the roads that are favoring the conditions I have. Now I have created an answer, and in the answer, I am checking my answer for the previous answer, and I'm calling my solve function. Now let's see what will the solve function will be returning. Here's our solve function. The solve function, I have make the max d equals to -1, which is our global variable, and we have created another variable named as node, right, which is also our global variable. And here in this, I have initialized it with -1. Now I'm calling my DFS. Now I am calling my DFS. And what are these parameters? What are these parameters? U, -1 and 0. So in the solve, I have passed a particular node. So I'll be passing that node as my initial point. It is the starting point, start point, and it is my farthest node. It is my parent node, right? As I don't know which will be my parent node, I will be passing -1. And in the D is the distance. I don't know the distance currently, so I'll be passing 0. So if visited equals to 1, now I'll mark my current node as visited, and I'll check if current distance is greater than my max distance. Then we will update our max distance with D, and we will make our node equals to U, because it will be one of the farthest node, right? If my current distance is greater than my max distance, then I can say the node from which I was calculating is one of the farthest nodes, right? And now I'm traversing all the nodes that are connecting to my node U. Let's say it is connected to 1, 2, 3, and 4. Now I will be ignoring my parent node, because if I will traverse the parent node, I have already traversed the parent node. If I have the parent node, then I'll be ignoring it. And what I've got, I am calling DFS of V, U, and D plus 1. Now what is this? Now for each node, currently I am standing at node 1. I'm calling node V. Let's say it is connected to node 2. So this V will be the second node, and U, this is the parent node for this node. And now what will be my distance? As I'm moving to this node, the distance will become D plus 1, right? So now from this 2, as the recursion will work, if I go to this 3, this D plus 1 will increment once more, and now it will serve as my parent node, and this will become my start point. So this function will store the distance maximum distance in the max D, and my farthest node will be stored in the node, right? Now what I'm doing here, I am making my max D equals to -1, which we have calculated. I am making it again as -1, and I'm calling my DFS function again, but in this I'm calling it from node, not from the U I have called. So with the help of this U, I have found one of the farthest node. Now from that farthest node, I'll be calculating which is the farthest node from this node. Let's say it is somewhere here, and this U was here, right? I'll be calculating other farthest node, and the distance between them, I'll be storing it in the max underscore D. So this will give me the diameter, and I'm returning my max D will be now storing the diameter. I'm returning the diameter plus 1, which is the number of cities that I'll be traveling. This is what my solve function will return. My solve function will return the total number of cities which can be traveled for free. Now as I have called this solve function for each node. So we will be checking this for each node, right? And after checking for each node, our answer will be storing the diameter plus 1, which is the number of cities that we have, number of cities. And now I'm returning my answer, which will be my final answer for the number of cities which our geek will be able to travel for free, right? This was our last problem. What we have done, we have implemented DFS. Firstly, we formed a adjacency list, and in that adjacency list, we have implemented DFS. With the help of the DFS, we found the two farthest nodes, and with the help of those two farthest nodes, we calculated their diameter, and we have done this for all the nodes that we have, all the different nodes that we have, and we compared all those diameters, and I'm returning the maximum diameter plus 1, which will be the maximum number of cities that I will be traversing, right? And this was our last question. I hope you all understood it. Thank you for watching.